Yeah. Last video I have discussed up to the instruction pointer. Okay. Then we'll go for the next. So what is this instruction queue? Because this is an instruction queue which is introduced from the 8086 onwards, which is caused to increase the speed of your processor. Because when I want to interface my processor to the any memory devices, it has to be work faster than that of memory. But in case of previous operations, processor speed is less compared to the memory, which means that when the memory gets more faster compared to the a processor, but 8086 onwards, processor get faster compared to the memory by using the concept called as a queuing concept or a pipelining concept. So it is a group of first in first out in which a 6 byte of instructions code is prefetched from the memory, which means when execution unit want to be execute, this bus interface unit or instruction queue fetches some 6 byte of information readily available for execution unit. This is done in order to speed up the execution by overlapping the instructions fetched with an execution. This mechanism, what is fetching of a mechanism to speed up your processing, called as a pipelining concept. Then we'll go for an execution unit. So execution unit, as we said, that just only execute the instructions. The execution unit just only decodes and execute the instructions. Okay. So it is having a 16-bit ALU which is going to be perform your arithmetic and logical operations, and which is having a 4 general purpose registers called as AX, BX, CX, DX. Beauty of this architecture is that if I want to be used for the 16-bit operation, I can use these registers as a 16-bit register, which means I can use 16-bit registers. Then I need to be called as a AX, BX and CX, which are used for a 16. In case if I want to go for an 8-bit operation, these registers can able to be split to 2 registers also. Like I can use for 8-bit operation AH and AL, where AH is a higher byte of accumulator register AX and AL is called as a lower byte of, and so on, BHBL, CHCL and DHDL. And it is having a 2 pointer registers, stack pointer and base pointer, and index registers, source index and destination index. All these are in 16-bit in size. So along with this, as I said that AX can be used for the AH and AL, BH used for BH and BL. So 8-bit operations also I can able to utilize these 16-bit register by splitting AH, AL, BH, BL, CH, CL and DH and DL. So these are the some of the functions. The main concept of execution units are general purpose registers, ALU, special function registers, instruction decoders and flag registers. So this is fetch the instructions from the queue in a bus interface unit, decodes and execute arithmetic and logical operations using an arithmetic logic unit. It sends the control signal to the internal data transfer operations within the microprocessor. It sends a request signals to the BIU to access external modules. It operates with the respect to T states, clock signals, and not on the mission cycles. Okay, because as I said that a bus interface unit works function based on only the mission cycles, whereas execution unit will work based on only in the T stage. So 8086 having these are the 4 general purpose registers. Next, so if you come for the general purpose registers, it's having a AX register which can simply called as an accumulator, which is going to be used for all the arithmetic and logical operations, because it should be mandatorily included or need to be specified when you want to be perform any arithmetic and logical operations. BX registers is simply called as a memory pointer, and in data segment in other addressing modes it can be used for the base registers. So only BX can call it as a base register. And CX is a counter register used in specifically in loop operations or loop instructions are executing. And DX is used specific operations like divide and multiplication operation. The DX registers need to be mentioned. So this DX register can also called as a data registers. So the index registers, we have a two index registers, source index and destination index. These registers are mainly used when I am going to be using any string operations. We have a pointer registers, base pointer and the stack pointer registers. These pointer registers are points the data when in the stack segment, and this specifies the memories in the stack segments. And the flag registers, these registers are used to indicate or specifies the condition or the status of the particular results when we are executing some instruction which is given by flag registers. So let's go in depth details about execution unit, stack pointer and base pointer. As I said that these are used to access the stack segment data. Stack pointer used as an offset address for the current stack segment during an execution instruction involves the stack segment for the. What is this means? As I said that previous example, as we see that for the code segment instruction pointer is used as an offset address, whereas for the stack segment source pointer or a stack pointer is used as an offset address. Okay. Then the content of stack pointer is automatically updated, that may be increment or a decrement due to the execution of push and pop instructions. This stack segment data can automatically increment or decrement depends upon the type of instruction which is executing, like a pop or push instructions. Then the source index and destination index, these are used for indexing an address and which is used for to specify, as I said that for any looping operations or jump operations I will go for this. Then the flag registers, as we said that these flag registers, there are, even it is a 16-bit register, we are going to be used only 9 flags. In that 9 flags, the 5 flags are called as a 5 flags are called as a status flags. These flags are called as a status flags. And other 4 called as a conditional flags or control flags. Other 4 are called as a conditional flags or control flags. Okay, so we'll see individually. So the bit 0 indicating a carry flag. This flag is set when there is a carry out of MSB in case of addition or a borrow in case of subtraction. This particular bit goes to be high whenever any arithmetic operation, addition or a subtraction done, in that if any carry or a borrow generated as an MSB. So the bit number 2, bit number 1 is not used. Bit number 2 is called as a parity flag. This flag is set to 1 if any lower byte of a result containing even number of ones or odd number of ones, this flag goes to be reset, which means that when I am checking my result, when the lower byte of the result having even number of ones, this particular parity bit is going to be set. Otherwise, it will be in reset condition, like as a 0 condition. So the third bit is not used again, and the fourth bit is nothing but an auxiliary carry flag. This is set if there is a carry from lowest nibble, which means that whenever I am performing any arithmetic operation, when the first 4 bits is generating any carry during that is bit 3 during an addition or borrow from the lower nibble, this particular bit auxiliary carry going to be set, otherwise it will be in 0. The bit 5 again not used, and bit 6 is for the 0 flag. This flag is get set whenever any execution result is 0 or when I am performing any comparison operations. If two strings or two numbers are compared, when both are equal, then obviously this 0 flag going to be set. And the 7th bit is called as a sign flag. This particular flag indicating whether my result is a positive or a negative. These 5 are called as a status flags, which will give a status of current execution of my program. Then the bit 8 is called as a trap flag. This flag is set when the entire process want to be executed in a single step, which means that whenever I have wrote some program, if I type executed, entire program is executed, which will send the result. But if I want to execute instruction by instruction, this particular flag need to be set. So earlier I said that it is a conditional flag. Next one is called as an interrupt flag. This particular interrupt flag will be enabled when I am executing or any instruction to that. Interrupt is mask interrupt or non-maskable interrupt is generated. Then the next flag is a direction flag. This particular direction flag tells about if the particular lower byte or higher byte of a data is used for transmitting a data in lower, that is left to right or right to left. And the final condition flag is an overflow flag. This particular flag going to be set whenever my result is overflowed. This is get only occurred when I am getting a 4-bit multiplication. More than 4-bit, this particular flag going to be set. Next, what is the mode of operation? Because as I said that it's going to be operate two modes, minimum mode and maximum mode. Let's see what is the minimum mode and maximum mode. A minimum mode of operation. A minimum mode can add any other a single processor. And 8086 is responsible to generate all the control signal on its own in the minimum mode of configuration. Primarily used this is a very simple applications. The minimum mode is working. In this mode is pulled up when I am using a pin number 33. Okay, it is not 30. When the pin is number 33 goes high or it is connected to the plus 5 volts, this minimum mode goes to be active. Similarly, maximum mode you are allowed to add additional processor called as a co-processor need to be attached, that is an 8087 arithmetic processor is need to be connected, and you could have an additional bus controller, and you have a fairly complex applications and difficult applications. We are going to use this particular mode of operation, and this particular mode need to be activated when you connected your pin number 33 to the ground pin, so that this mode can be enabled. So this is the end of 8086 architecture and the different modes of operation. And the next class we are going to see about the different pin out diagrams of 8086 and each pin how it going to be operate. Okay, because in the next class only we can know that in the pin configuration also we are using two separate pins. Our separate pins are for minimum mode and a maximum mode, and some of the pins are common to these things. So up to that, please read of 8086 architecture and the modes of operation, and you need to check whether where we can use these modes of operation. And thank you very much. Happy reading.